Okay, so we've graphed inequalities. Now let's solve some inequalities. What if I asked you to find all the solutions to x plus 4 is less than or equal to 7? What are all the numbers that make that inequality true? Well, we know how to solve equations. If it was x plus 4 equals 7, that's easy. We already did a unit on solving equations. I want to get x by itself, so I would do the opposite of add 4. So I would subtract 4 from both sides. And we learned that with an equation, it's a balance, and so the left side is equal to the right side. And as long as we do the same thing to both sides of the equation, the equality still holds. So in this case, the 4's cancel, that equals 0, and x plus 0 is just x, equals 7 minus 4 is 3. But will that work if this is an inequality? Seems like maybe it should, but we have to be a little careful and not just jump into it without thinking. Let's look at a few examples. We know, for example, that 5 is greater than 2. What if I add the same amount to both sides? What if I add 8 to both sides? Will the left side still be greater than the right side? 5 plus 8 is 13. 2 plus 8 is 10. 13 is greater than 10. So yeah, that seems to work. But that's only one example. That doesn't prove it. What if I subtracted the same amount? How about if I take away 5 from both sides? Let's see if the left side is still greater than the right. 13 minus 5 is 8. 10 minus 5 is 5. Yes, 8 is still greater than 5. So it seems like adding or subtracting the same number to both sides keeps the inequality true, or it preserves the inequality. What if we look at, a negative number? We know, for example, that negative 6 is less than negative 4. What if I add the same amount to both sides? What if I add 5 to both sides? So negative 6 plus 5 is negative 1. Negative 4 plus 5 is positive 1. Negative 1 is still less than 1. So it seems to work there as well. What if I subtract the same amount? What if I take away, 3 from both sides? What happens? I get a negative 4 and I get a negative 2, and negative 4 is still less than negative 2. Now if you think visually on a number line, that if we have 2 points on the number line, let me put a few points here. Let's say we have a point that's over here and another different color. Let's put another point over here. That if I add the same amount, the red one is still going to be to the left of the green one. And likewise, if I subtract the same amount, subtract a couple, whatever, 4 let's say, and then subtract, then the one where the red ends up is still going to be to the left of where the green is. So it seems like it should work that I can add or subtract the same amount to both sides of an inequality, just like I did with an equation, and that would preserve the inequality. So adding or subtracting, and remember subtracting is just adding the opposite, the same number to both sides of an inequality preserves the inequality. That means that the inequality symbol stays in the same direction and it's going to be true. So let's go ahead and solve this original equation. We have x plus 4 is less than or equal to 7. Earlier I did greater than. So I want to get x by itself, just like I would for an equation. So I'm going to subtract 4 from both sides. And the inequality is preserved, so I'm going to put that down here before I do anything else. So the left side should still be less than or equal to the right side. Now what do we have on the left side? The 4's cancel and give us 0. X plus 0 is x. And 7 minus 4 is 3. And so there's your solutions. That's the symbolic representation. X is less than or equal to 3. I could graph that. Here's 3 on the number line. less than or equal to, that's a closed circle, because it could equal 3, and then less than goes to the left. So that's a graphical way of representing the solutions. Or we could also do interval notation. Less than or equal to 3 means from negative infinity to 3. Parenthesis around negative infinity. We never include infinity or negative infinity. We're going to include the 3 though, so instead of a parenthesis we use a bracket. So 3 different ways we could represent our answer for the solutions to that inequality. Alright, so remember, you can add or subtract the same number to both sides of the inequality when you're trying to solve it. So this one says graph the solutions to n minus 8 is greater than 12 in a number line. So this one's specific. It wants you to put your answer as a graph. Alright, so let's solve this. So the first thing I want to do is get n by itself. So I'm going to add 8 to both sides. That'll preserve our inequality, so it's still going to be greater than. And on the left side, the 8's cancel, and I'm just left with n. And on the right side, I get 20. So n is greater than 20 is my solution. So I want to graph this. So put 20, I know it doesn't matter, I'll put it right here. Greater than, so that's an open circle, because it can't be equal to 20. And then greater than goes to the right. And that would be it. Simple enough. Express using interval notation, what would that look like? Well, we're going from 20 to infinity, parenthesis on infinity, and on the 20 we're not including it, it's an open circle, so we use parenthesis there as well. And that's it. Alright, let's take a look at another one. Solve this one. You might want to hit pause and solve it just to make sure you've got the understanding here. Okay, and it doesn't say how to express our solution. So, I want to get x by itself. What's the opposite of subtract 15? That's add 15. That preserves my inequality. The 15's cancel, so I just have x. 9 plus 15 is 24. And there's my solution. Any number greater than 24, 24.01, 26, 32, 99, 785.5. Any number that's greater than 24 is a solution. Okay, how about this one? Solve negative 8 is less than or equal to 3 plus x. How is this different from the ones we've done so far? Well, the x is on the right-hand side of the equation. So, if you wanted, if that bothered you, instead of saying negative 8 is less than or equal to 3 plus x, we could have said 3 plus x is greater than or equal to negative 8. But you don't have to. We can just work with the original. Now I want to get x by itself, so I have to get rid of this 3. To get rid of it, I'm going to have to subtract 3 from both sides. So that'll preserve my inequality, so it's still going to be a less than or equal to. 3 minus 3 is 0. 0 plus x is x. And then negative 8 minus 3 is negative 11. Now we could write it the other way. We could switch the order. Instead of negative 11 is less than or equal to x, we could say x is greater than or equal to negative 11. It didn't say to put it, to graph it or use interval notation, so I'll leave it like that. Now it actually is okay if you left it like this. Just be careful in the directions. If they want you to have the variable on the left side, then you might rewrite it the way I did here. But otherwise it's fine. And if you actually wound up solving this one, the x would have been on the left side and you would have come up with that answer. But like I say, it doesn't really matter. Both of those are equivalent. Okay, what about compound inequalities? We spent a little bit of time graphing with inequalities with or and. So what we're going to do for this, solve y plus 6 is less than negative 5 or y plus 4 is greater than or equal to 1. Well, let's just treat them individually. Let's start with y plus 6 is less than negative 5. We're going to subtract 6 from both sides to get y by itself. Our inequality is going to stay in the same direction. The 6's cancel, so I have y plus 0, which is y. And on the right side, I'm going to get negative 11. So y is less than negative 11. And then we have or. Now let's solve the other one. We're going to subtract 4 from both sides. We'll be left with y greater than or equal to -3. And now we know how to graph these. You don't have to do them separately to get your final answer, but just as a reminder. So y less than -11, open circle, that goes to the left. Y greater than or equal to -3, that's a closed circle, goes to the right. Now how did the or work? The or meant that if we put them on top of each other, we want everything total. So if I combine these two graphs, that's close enough, that's going to be my final solution. So I'll graph that on this final one here. So I have an open circle going to the left, closed circle going to the right. So -12, -13, -20, those are all solutions. -2, -1, 0, 10, 20, 56, those are also solutions. Remember with an or, at least one of the, let me circle them, at least one of these two statements has to be true when you plug in a number for y. They don't both have to be true. They could both be true. In this case, that's going to be impossible. But sometimes you could get it where both will be true for a certain value of y. But at least one of them has to be true. What about an and? Let's look at one last example. Now, this is a little different. Remember, this was the shorthand notation for a compound inequality using and. So if it was written separately, it would be 14 is less than c minus 8, and c minus 8 is less than 23. So let's go ahead and do it this way. We'll do them each individually. So here we have c minus 8. I want to get c by itself, so the opposite of minus 8 is plus 8. So I add 8 to both sides. That preserves my inequality. 14 plus 8 is 22. The 8's cancel and I just have c. If I want to flip that and say c is greater than 22, it's the same statement. Now let's work on the other one. Same idea. We're going to add 8 to both sides to get c by itself. That preserves our inequality. The 8's cancel and I have c on the left. 23 plus 8 is 31 on the right. So c is greater than 22. Open circle, greater than goes to the right, and c is less than 31, another open circle, going to the left. Now remember how the and worked. Both of the statements have to be true when you plug in a value for the variable. And that would mean that if I put one graph on top of the other, if one graph was yellow and the other one was blue, what would be green in the picture? So if you can think of that as the yellow over the blue, where they overlap would be green, what would that be? Well, that would be everything between the 22 and the 31. So for our final answer on a graph, it would look like that. Now also, if it doesn't specify, we could have just written our answer that way. Or shorthand notation, 22 less than c less than 31. Any one of those would be fine. Now one last quick thing here. If we took this original, let's clone that, move it down here. You actually don't have to separate them to solve it if you want. You could think of this as, well, there's 3 parts. We have the first part, the second part, and the third part. So as long as we do the same thing to all 3 parts, we can solve this. So you find your variable, it's in the middle. We have c minus 8, so we want to get rid of the minus 8. So we're just going to add 8 to all 3 parts. And that preserves the inequalities, so those stay the same. 14 plus 8 is 22. Minus 8 plus 8 is 0. C plus 0 is C. 23 plus 8 is 31. So I just split them up to make sure you understand that this is an and, but you notice we get the same answer either way. Okay, you should be ready now to work on the worksheet.